to today's video. Today's video is all about block creation. We're going to go from the very beginning of creating a block all the way to the very end. We're going to go over the different options that we have to apply to a block, and we will kind of walk through it in hopes that you guys get a better understanding of how blocks work and maybe inspire you to create a block, right? And use the different parameters and different constraints and different tools that you can add to your blocks, like visibility states. And hopefully you are inspired and you become a little bit better at block creation. If by the end of this video you have learned something new, like, comment, share. If you didn't learn anything new and you know some cool tips and tricks about block creation that I did not cover, also, just comment below. I'd love to hear about it. With all of that being said, let's get started. All right. So I guess the first thing to talk about is how do we create a block, right? So there's one thing that I always like to point out to people is that CAD has this thing called the noun verb syntax. The noun verb syntax. What the noun verb syntax means is that you can either select the object and then enter the command, or enter the command and then select the objects, right? So for example, if you want to move, so here I'm going to draw probably the worst bike you've ever seen. So we're going to do a little circle, copy our circle, move it to the side, and we're going to maybe draw a triangle, and that was going to be our little makeshift bike. So let's say we want to move our bike. What the noun verb syntax says is that we can select the objects first, type in our command, and then follow the prompt to specify the base point, and we can now move our bike. Right? See it travel across the screen. Or what we can do is we can enter the command first, then select the objects, then hit enter, and then specify our base point, and we get the same result. That is the noun verb syntax. Either select the objects first and then type in your command, or type in your command and then select the objects. You're not wrong either way that you do it. Some people find it more efficient to do it one way versus the other, but there really is, it's all about you. What's more efficient for you, what you feel more comfortable doing. All right. The reason I bring that up is because now if I can select everything, so I can select my two circles and my polyline, and I can type in block, and what you'll see is that the block definition dialog box appears with a little image that shows the bike that we created, right? Or we can have just typed in block and then nothing would be here, and then we can select the objects that we want to be a part of the block later on. Or we can just not select anything and draw our block inside of the block editor. But what we're going to do right now is we're just going to go through this dialog box really quickly. So what is our first section here? The first section here is the base point. What do we want to specify as the base point of our block? Okay. And we have three options. We can specify on screen. If you select specify on screen, what that means is that after you fill everything out, so after we go through all of these different options and we apply all these block definitions, when we hit OK, AutoCAD will prompt us, or Civil 3D, will prompt us to select the objects that we want to be a part, or to select the point that we want to be our base point. If we choose pick point, the moment we click this, you'll see that the block definition panel goes away and it prompts us to select what our base point is going to be. So for example, if I was to click this and I go and I say it's going to be the center of this circle, then you can see here that that is now the applied base point. All right. I'm going to set this back to 0 and set this one back to 0. If you do neither, then it will default to 0, 0, 0. And please remember to change it later. You really want to always apply a base point to your blocks. Next, you have your object selection. Okay, see here we pre-selected our objects, so we have it here. But we can also do the same thing as we did with the base point, where we specify on screen, which means, again, after we fill out all our definitions and we hit OK, it will prompt us to select the objects that we want to be a part of our base point. If we do select objects, the same thing will happen as we did with pick point, where we are then, this dialog box goes away and we are prompted to select the objects that are going to be a part of our block definition. And after we select the objects, we hit enter, the dialog box will return. This button that you see here is your quick select option. This will bring up the quick select menu, which will allow you to go ahead and basically select the objects that you want to be in your block, but it's sort of in a list format. So for example, if I want to do this, I can select the polylines, color of the polyline, layer, line type, any of these options, the operator, equals, not equal, or select all, and then the value, right? So if we say polyline, and then I say that it's on layer, equals any one of these layer, it will look in CAD for any of the polylines that are on that layer. I personally do not like using the quick select for block creation. I feel like so many things can go wrong. There could be something that you're not seeing that's just out there. Then you'll bring in a line that you didn't intend, or in order for you to use this for block creation, you have to really, really know your block. I just personally don't like it, but if you do and you have some tips and tricks about using this to build a block, let me know. I personally myself don't like it, but to each their own. So I'm going to hit cancel on this. Down here you have three options: retain, convert to block, and delete. So what this does is that if I select retain, then that means that the objects that I have selected on screen to that I have pre-selected on screen to be a part of my block definition using any one of these methods, once the block is created, retain says that it will remain its individual object. So for example, if I go ahead and I select these objects and I say, oh, I want this circle and I want this line and I want this circle, and I hit enter, then what retain says is that after the block is created, this will remain two circles and a polyline. It will not convert this image that you see right here, or these objects that you see right here in my model space will not be converted into a block. It does not mean that the block is not created. It just means that these specific entities will not become a block. Convert to block does the opposite. It says that the objects that we do have selected will then become a block. So with all of these definitions applied, so these three objects that we selected here, post creation of the block, post creations of the block will remain a block. Delete says that post creation of the block, the objects that we have selected to be a part of our block definition will be deleted. Under here you have a counter that lets you know how many objects are currently a part of your block. So right now we have three objects, right? Two circles and a polyline. Now we're up to behavior. So behavior, what this says is we can make our block annotative. We can then have this option here. So in order for this match block orientation to layout to be active, the block must be annotative. What this match block orientation layout does is it ensures that when you go to insert your block, it matches the orientation of the UCS. Okay. So, right now we have our UCS right here that is unnamed. And for example, if we have this block and it's going to be inside of a viewport with a UCS that maybe is at a different angle, then the block will match the angle of the UCS, or the rotation of the UCS. Scale uniformly means that on the X, Y, and Z, it will scale equally. When you have this turned off, then you can scale X separately from Y, separately from Z, right? You can scale it at its individual, at the individual level, the X, the Y, or the Z individually. Allow exploding, and so when this is has a check mark in it, we have specified that the block can be exploded post insertion into the DWG. When this is unselected, then the block It cannot be exploded. Okay. So up to you. And then over here we have settings. Of course, you have your units where you can match. You can decide what units your block is to be. And then we have this hyperlink button. So what we can do with this hyperlink button is actually pretty nifty, right? So let's say we were drawing a part or a model of something like a screen model or something like that. What we can do is we can hyperlink it to the spec sheet. If one exists, we can hyperlink it to a DWG. We can hyperlink it to a page or a tab, a layout tab. We can hyperlink it to wherever we want. So for example, if this was a real bike, I don't know who would ride this, but if it was a real bike, we can hyperlink it to the maybe the manual for the bike. We can create that hyperlink so that now anytime we insert this bike, we can hold control, click on it, and it will direct us to that bike or to the manual for that bike, whether it be on a website, whether it be on your server, whether it be in another DWG, or whether it be in one of the layout tabs. It will direct wherever you tell it to. It will take you there. Description. I always recommend putting descriptions for everything that you do. It's not so much for you, but for the designer or technician that comes after you. You want them to be able to kind of, get up and go, right? I always tell people that, like, no designer or technician wants to spend time deciphering what was the last thing that you did, right? We already know we're drafters, engineers, technicians. It's going to be, chances are, we already have a lot to do. So the last thing I want to do is figure out what your layer means, or figure out what your block means, or what your block is supposed to be used for, or what your layer is supposed to be used for. So just throw in a description, make it easier for us to say, okay, well, this is what this is intended for, right? So here, for example, if this was, if I am a bike manufacturer or a bike designer, and this is a mountain bike, a 5-speed mountain bike or something like that, then in my description I would say that this is the latest 5-speed mountain bike. That makes it easier for the next person that comes after me to know what the intent of this bike was, right? Yeah, and that's your, oh wait, nope, yeah. Of course, this here is open in block editor. So this just tells you, once you click OK, if I click OK and this is unselected, we will remain here in model space. The block will be created, but we would stay here in blocks in model space. If we hit this check mark right here, then it will direct us and take us into the block editor space, which is a separate space from model and paper. It is a whole different design area. And for now, that's where we want to go. We want to go to our block editor. Up here, of course, let's just name this. And let's just name it bike or something. I don't know. And we'll say OK. And as you can see, it takes us into this gray screen area. And this is our block editor. Okay. This is where we can make additional edits and additional changes to our block. We can add now. We can add more to our block. We can make changes to our block. So we can add dimensional constraints, geometric constraints. We can add attributes, definitions, visibility states, block tables. Really, the options are limitless to what we can do in here. So let's start by going over what we have up here in our ribbon. If you did not know, whenever you see this blue ribbon, this is called a conceptual, or this blue tab here, this is called a conceptual tab, okay? This tab is related to the objects or to the current object or current space that you are in. Sorry about that. To the current object or current space that you are in. So, for example, we have here, because we are in the block editor, this is our block editor conceptual tab. So this is everything related to our block, right? You'll see it sometimes when you're dealing with a surface. If you select the surface, you'll sometimes see that this will have the surface and then name of the surface and then all the options that are related to that specific surface. So this is our conceptual tab. And if we look at our conceptual tab, we go from left to right. What we have here is edit block. I really don't know why this is already here. But if we were to click this right now, it would have us go find another block that we want to edit and then open that block. Here we can save our block without closing our block editor. So if we made some changes, we've been building in here for a while, we can quickly hit save and it will update the block definition and it will save our block as it is. Here is where we can test our block, which we will be using here in a little bit after we apply some constraints and some parameters, right? Then we'll want to go into this test block space to see if it actually works, right? Or if we did it right, or if we need to make changes. We can do that in our test block area. Here we can do a save block as. This is good for if we are just modifying an already existing block and we're just making a couple tweaks and changes to it to fit or suit our needs. What we can do is we just say, hey, save as, create a new name for the block, and now we have a separate block without altering the original. Our next panel that we see here is going to be our geometric constraints. Okay, our geometric constraints are going to apply to any of these objects that we have in our block. So let's go through them. So I'm going to delete this bike really quick, and we are going to do we're going to apply some constraints. So if I have a polyline, let's say I have two polylines here. I don't know what they represent, but let's just say we have two polylines here. Auto constraint, what auto constraint does, it will apply all the possible constraint. It will apply all the constraints possible that suit these two lines, right? Or they can be applied to these two lines. So if I hit this button, it will say select the objects. If I select these two lines and I hit enter, you will see that it applied two constraints, right? It applied a parallel constraint and it applied a horizontal constraint. Okay. All right. So, and that is what the auto constraint does. It's based on the objects that you select and how you have them within your space. So next we have, this is going to be our coincident constraint. What this does is it is going, this should not be here. So here we have two lines, okay? And so what I can do is I can select coincidence. I can select my first point, so let's say this point here, and then select my second point. And so if I choose, for example, this point, the midpoint, I can select that one. And notice that they snapped to each other, okay? Now what happens is if I move, you can see that I can still move this one and this point stays where it's at. But watch what happens when I move it from the midpoint. See, it kind of remains tied to that midpoint of the line, okay? Because of the coincident. So even if I move this one and I move from this point, it will take that point of the line with it. Right? It's kind of cool when you do that, doesn't it? I know. So that is your coincident point, okay? Our next point that we have is our parallel. So what is our parallel? So what a parallel does is if we have two lines, like so, and I apply the parallel constraint, if I select this line and I select this line, these two lines will remain parallel to each other no matter what you do. So you can move it this way, they will always remain parallel. Okay. Now we can move them. Of course, we can separate them, we can bring them closer together, but where one goes, the other will follow, right? In order to maintain its parallel configuration. Okay. Alrighty, so that is our parallel constraint. All right. Next, what we have here is this one that has a circle and a line on it is going to be our tangent. So for a tangent, we are going to need a circle. So if we have this circle and I draw a polyline like this, and I select our tangent constraint here, I can select the object. So I'm going to select this circle and I'm going to select this polyline, and you can see that they snap together, right? And so I can move the line, but the circle will always remain tangent to the line, right? I can move the circle and the line. The line will be tied to the circle, right? All right, let's delete these. Next, what we have here is our collinear. And like it says here, it constrains two lines to lie on the same infinite line, okay? So if I have this polyline here, right, and I draw another polyline, let's say I draw a polyline down here, and I go ahead and select this, I will see here that I can select the first line and I will select the second line, and they snap to be on the same plane, okay? And they are going to be tied to always remain on the same plane, okay? Along the x-axis, they will always remain together, as you can see here. All right. Go ahead and hit exit here. We'll delete this one. All right. Next, we have our perpendicular. Okay. Whoops, I need the lines first. So if we draw a polyline and we draw another polyline, then what we can do is we can apply the perpendicular constraint, which will ensure that these two lines are always perpendicular. All right. Next, we have our smooth. This constrains a spline to be, This constrains a spline to be contiguous and maintain G2 continuity with another spline, line, arc, or polyline, okay? So now, let's go ahead and do that. So if I have a spline here, I'm going to just draw a spline. Nice, nice, nice. Whoops. Oh, no, sorry. I hit escape by accident. Let's draw a spline. Okay, we have one spline there. Now, if I was to draw another spline. Okay. Now, if I go ahead and I hit smooth, then what's going to happen is if I select this spline curve and then I select this spline curve, you see that they snap together. Okay. They are still separate curves or separate splines, but they are now tied together. All right. Let's go ahead and delete that one. Here, what we have is we have our concentric, okay? This applies to circles and arcs. So if I go ahead and I draw a circle here and I draw another circle, I can make them concentric to each other, okay? So I can go ahead and I can select the concentric circle. I can select the first one. I can select the second one, and they will always share a common center point no matter what I do, okay? I can't move one without moving the other. All right. All right. Next we have, all right, so these two are pretty interesting. One is horizontal constraint and one is a vertical constraint. So what this does is it constrains lines, all right, to either the y-axis for the vertical or the x-axis for the horizontal. So if I go ahead and I draw a polyline here and I apply a horizontal constraint, then as you can see, typically what would happen to this line if it was not constrained, I would be able to grab this this grip point, and you can see that I can kind of rotate the line, or I can move it any way I want. This one, it is locked. I cannot rotate this, right? I cannot move it from lying on the x-axis, and it does the same thing for the y-axis, which is going to be your vertical constraint. All right, let's go ahead and delete those. All right, so next what we have is what is called our symmetric constraint, okay? So our symmetric constraint constrains two curves or points on object to maintain symmetry about a selected line, okay? So for example, if I have, for this, I'm going to have to use 3 lines, okay? So one line is going to be what is considered our mirror line, okay? This is going to be our mirror line. So if I select here our symmetric constraint, and I select our first object, this line, we want this line to always remain symmetrical to this line. Then now it's going to ask us for our line of symmetry, or our mirror line. And if we select that, they are now constrained to always be symmetrical. So as you can see, if I move this one, the other one moves a equal distance about the mirror line. All right. We can delete these now. And our final one is equal, which constrains two lines, or constrains two lines or polyline segments to maintain equal lengths, or arcs, and circles to maintain equal radius values. Okay, so if I draw a circle, I'm going to draw another circle, and if I go ahead and hit equals, then if I select this object and I select this object, now they are constrained to always be equal. So if any change I make to one affects the other. So if I increase the diameter or the radius of this one, the subsequent circle will do the same. It will expand by the same amount. They will always be equal to each other. And that, my friends, is your geometric constraints.